Today we will start with this question. It is given that explain that friction is a necessary evil. So friction is necessary because it has some advantages, but it is at the same time it is evil also because it has some disadvantages. Now we will describe or we will discuss the advantages and disadvantages. So first one, advantages. Some uses of friction or advantages of friction. So number one is friction helps in walking. So that means in absence of friction, we will not be able to walk on any surface. Instead, we will slip on the surface. Okay. So without slipping, we can walk on a surface, that is due to friction. Next one, motion or speed of vehicles can be controlled. Like when brake is applied, a vehicle comes to stop. Because of what? Because of friction. Okay. Next one, we cannot write without friction. Obviously, if friction is not there, friction between the ball of the pen and the paper surface, because friction is there, that is why only we are able to write. Otherwise, we won't be able to write on any surface. The next one, we can hold objects due to friction. Okay, so these are the four advantages. Apart from these four advantages, we have many advantages. If you want to include some more advantages, you can. Uh, then next we'll see disadvantages of friction. So in disadvantage, the first one is due to excess friction, components of machines gets deformed. There are different machines where friction is not it is not desired, but still we get friction. So in that case, what happens? There may be deformation in the different parts of a machine. The next one, friction reduces the efficiency of machines. So in the efficiency of machines, that will be reduced due to friction. Okay. Another one, it causes loss of energy in the form of heat. So there are many places where heat is not required. Just an example, this is not due to friction, just I am giving one example. Suppose sometimes when a certain apparatus, certain electric apparatus, it runs for a long period of time, we get some heat there. That heat is not desired, we don't want that heat, but that heat is developed, and if heat is developed, that means some type of energy is lost in the form of heat. So in the same way, in different machineries, what happens when friction is there, due to a huge amount of friction, there will be generation of heat. So if heat is generated, that means some amount of energy is lost in the form of heat, which is not desired. And why we are getting heat there? Because of friction. So friction in that case is a disadvantage. The next one, okay, no, we have discussed all the 3 points. So in the conclusion, you will write, since friction has many advantages, at the same time many disadvantages, it is called necessary evil. Okay. Then we will move to the next topic, which is rolling friction. So here I will tell you what is rolling friction. Rolling, because in previous cases we discussed about static friction, we discussed about kinetic friction, and we discussed about limiting friction. So rolling friction, generally this rolling friction is obtained for specific shapes of object. Suppose for example, that is a surface. On this surface there is a ring or any circular object or any spherical object. We can allow this ring or spherical object or a cylindrical object to roll on the surface. Okay. But all the objects, like if there is instead of this ring or sphere, if you take a wooden block, then certainly this wooden block will not roll on the surface. So that is why rolling friction is obtained only for specific shapes of object. Okay. Now we will describe what is rolling friction. Now see, suppose there is a surface. On the surface we have a circular object. Okay, and this is the surface. Now this surface, theoretically this surface is touching the object only at a certain point. This is the point. Suppose this is P point and the object is rolling. The object is rolling in this direction, suppose in clockwise direction. So obviously after in the next instant of time, this point P will not be here in this place, but it will be somewhere here. Then in the next moment it will be somewhere here. That means point P is not a fixed point which is in contact with the surface. Okay, and moreover this point P is a small point. So small point means uh, we can say that there will be less friction, because friction depends on surface area. Okay, suppose instead of this object, this spherical or circular object, if we take a block like this, then this part of the block is in contact with the surface. So that means in that case friction will be more. So more the surface area, more surface area if it remain in contact with the with this surface, then there will be more friction. But in rolling friction, only a particular point remains in contact at a time with the surface. So the amount of friction is very less. In fact, theoretically this friction should be zero. Rolling friction, there should not be any existence of rolling friction actually. The reason is that because this object is not sliding on the surface, but the object is rolling. Okay, so that is why friction should be zero. But practically if this is a surface, if a sphere or any circular ring, if it is allowed to roll on the surface, after rolling to a certain distance it will stop by itself. So if it is stopping by itself, there is friction. In fact, there is some air resistance also, due to which this object is, after moving certain distance, it is stopping. Okay, so rolling friction, theoretically it should be zero, but it is not zero, because we see that when object rolls, after some time it gets stopped. Now we will see what are the factors on which rolling friction depends, or what kind of friction is that. So rolling friction, it is completely different type of friction. Earlier we discussed about static friction, kinetic friction, but rolling friction is quite different from those two types. Now suppose in rolling friction what happens is, if this is the surface, the object is this one, it is rolling, this point is in contact. But practically what happened, though theoretically we are saying that only one point is in contact, but practically if you see, this much area is in contact, this much area. So this area is not a point. Can you follow? So this area is not a point, and that is why due to this much surface which is in contact with the rod or with the this surface, what will happen? This object, it has a certain weight. Due to this weight, what happened is, this surface, the surface will depress down by little amount. The amount will be very small, though in the diagram the amount that I have drawn here, it is not much less, but practically this depression is very less. So this is the object. Okay, when the object is moving on a horizontal surface, the surface gets depressed down in this way, and as a result, when this wheel or whatever you say, this ring or sphere, when it has to move forward, it has to nullify, or it has to cross this part. This part means it is like a bump, this part. Okay, so to cross this part, it needs some effort. Can you follow? Suppose, for example, if this object is having, just an example, okay, if this object is having a original velocity 10 meter per second, when it is crossing this part, its velocity will reduce, right? Why? Because of friction. Alright, so this is the reason behind rolling friction. Why this rolling friction is coming in existence? Because of this thing. When an object, an sphere or circle or cylindrical object is kept in contact with this surface, then what happens? The surface in that particular region, it gets depressed down, and as a result, to cross this part of the surface, this object has to do some amount of work, and as a result there will be some obstruction in its motion, and this obstruction in motion is nothing but friction. Followed? Now this frictional force Fr, this one, It depends on three factors. One factor is it is inversely proportional to the radius of the object. This is a circle, sphere or cylinder, whatever you say, it has a radius. If this is the center, this is the radius r. So it is inversely proportional to radius. Then this rolling friction is directly proportional to area of contact. Okay, area of contact means this much area which is in contact with this surface, with the horizontal surface. And then it is again proportional to normal reaction. In last topics I already told you about normal reaction. When weight of the object acts in downward direction, normal reaction acts in upward direction. So this is this n, normal reaction. Now combining these three equation, what we can write? Combining these three equation, okay, I am writing it here. Fr, that will be equal to, see, this is proportionality sign, proportionality sign, proportionality sign. When it is removed by equal sign, we get a constant here. So mu is the constant, suppose. Apart from mu, these three equations we are combining. So on combining this, we are getting like this, An by R. Okay. So this is the expression for rolling friction. Alright. Now see, that is why, though the amount of rolling friction is not 0, theoretically it should have been 0, but practically it is not 0 because of this reason, no? That theoretically what we saw, that only one point should be in contact, but practically not only one point but a certain region of that particular object remains in contact with the surface. So that is why we get a non-zero rolling friction. But yes, the amount of rolling friction is, though it is non-zero, but it is less. And that is why suppose, just an example, suppose like this, there is a surface of a road, suppose, and here we have a wheel. A car is moving on the surface and we are considering one wheel of the car. So you can see that this wheel, why the shape of a wheel is like a circle, like a ring? The reason is that since the shape is like a ring, then only it will undergo, or it will show, or it will face rolling friction. It will not face any kind of sliding friction. Sliding friction means, suppose if this suppose there is a wooden block like this. Okay, this wooden block, it cannot roll. If it has to move, how it will move? It will slide from one end of the surface to the other end. In that case, a huge or a large area is remaining in contact with this road for all the instant of time. But if the shape is like this, like a circle, then only a small area remains in contact with the surface, and that also, this area is not moving in this direction, the area is moving like this. Okay, so that is why it is not facing sliding friction, but it is facing rolling friction, and that is why this shape is preferred, because the amount of rolling friction is much less than the amount of sliding friction. Okay, so I hope the rolling friction part is clear. Then in next video we will discuss about angle of friction, angle of repose, these things. So thank you for today.